Hello, hello. Welcome to Unit 2, Lesson 5, Applications of Inequalities. So, we've learned a lot about inequalities so far, and now we're going to be applying them to word problems, okay? So, similar structure to how the equation lessons went last semester, where, we learn, we practice, and then we apply. That's this too, okay? So, when you're talking in a conversation or in a word problem in math, you're going to find phrases that mean certain things, just like we did with equations, right? Some or more than, right? Those things mean to add. And so in this case, when it comes to inequalities, greater than, one common phrase would be more than, right? Either of those could pop up in conversation or in a word problem, okay? If it says greater than or equal to, right, or if that's the symbol that we need, you're going to be looking for phrases like at least, okay? I need to save at least $500, right? I'm happy if I save more than that, but at the very least, whatever I'm saving for, I need at least 500. So that means it's like, I'm okay with 500. I can include that in my answer, but if there's more than that or greater than that, that's cool too. So less than, this one kind of cracks me up. In your lesson, it literally says less than. You're going to see less than. So just be on the lookout for that, and you'll know what to use. And then for the symbol less than or equal to, that would be at most. So at most, I can spend $500 on a bike. Okay? Right? Something like that. At most, it's okay if I hit 500, but I can't go over that. If I can spend less than that, I'm good. Right? So those are just the different things that we need to be on the lookout for. As a reminder, greater than, that would be this symbol here. Okay? Greater than or equal to, that would look like this. So greater than symbol, but with a line underneath. Less than faces the other way. And then less than or equal to, same sign, with a line underneath. Okay? So just, those are hopefully are good reminders. Your lesson does give you steps on how to solve the problem. They're not super detailed. They don't tell you exactly how to solve the problem, but you're going to read the problem carefully. So find your phrase, right? Be on the lookout for one of those phrases. What kind of symbol do I need to find? Define your variable. So in the lesson, they use X a whole bunch. Maybe you're going to use D for dollars, or, there's other ways, other variables that you can use, but you need to figure out what is my variable representing also. And then translate the problem into an inequality. So basically, like, take the words and write it as an inequality. Okay? So let's go into our first one. This is number 1 from your practice as well. So if you want to take a look at that, remember, take notes on these, okay? I'm giving you answers to some of the problems that you have to turn in, so you might as well get them right, okay? And then you have solid examples that you can go off of. All right, number 1 says 10 less than twice a number is equal to at least 50. What are the possible values of the number? Write an inequality that could be used to solve the problem. Use x as the variable and write the inequality so that the x term comes first. Do not solve the inequality. So notice that was a big, long problem, and you might have even just shut down after that first sentence, right? But they do give us some valuable information. First off, if we look at the steps that we need to take, right? Read the problem carefully. Find your phrase. So with that, 10 less than twice a number is equal to at least, there's that phrase, at least 50, okay? So coming up here, which symbol has at least? Well, that's this one here. And if you need to, pause this video and write this down or screenshot it or something like that so that it can help you too. So I know that I'm going to need a greater than or equal to symbol. Okay, so there's my symbol. Then, what are the possible values of the number? Write an inequality that could be used to solve the problem. use x as the variable, so they told us the variable, okay, and write the inequality so the x term comes first. All that means is that it goes to the left side of the symbol. It's going to be over here. It doesn't mean it literally has to be the first thing. It's just on this side rather than on the right-hand side, okay? So, now let's build it. 10 less than. 10 less than. Well, let's see here. With that, and I just realized I have a typo. I messed up. And this should be 52. 52, not 50. Okay? Okay? Now, I know it can be kind of confusing because notice right here, 10 less than. Well, you're probably like, well, why didn't you use a less than symbol? Right? But because all this junk, that's what needs to go on the left. Whereas is equal to, and then after that says 52. So my 52 is actually going to come over here. All that other first stuff that's on before that in the sentence is going to come over here on the left. So 10 less than, if I have 10 less than something else, that means I took 10 away. Okay, so that means I'm subtracting 10 from something, right? From something. Well, it says 10 less than twice a number. Well, twice means to multiply by 2, and I probably shouldn't have put an x right there because then a number, we don't know what number, that's my variable, is the letter x. So 10 less than, that's 10 being taken away, twice a number, that's multiplied by 2, so 2x, right? And that's my variable, because a number, well, we don't know what number, right? And so that's our unknown right there. So 10 less than 2 times a number is equal to at least 52. Okay, at least 52. So what that means is like, it could be more than that, right? It could be equal to it, right? And so we have to include both of those. All right, so that's your answer to that when you're building your inequality. Okay, so we got to really pay attention to like what symbols are we using, what operations are involved, all of that. Okay, this next one is number 5 from your quick check. No, just kidding. Man, I keep misspeaking. Number 5 from your practice. Okay. Helena will receive $53 plus $4 per kid for babysitting this afternoon. She's hoping to make at least $69. How many kids does she need to babysit? She writes the inequality 4x plus 53 is greater than or equal to 69, where x equals the number of kids. Solve for x. Okay, so this time they gave us the inequality, but let's talk about how they built it, right? So it says x is the number of kids. Well, it's from what we can tell, she's gonna like receive a flat $53. Like she gets $53 no matter how many kids show up. Okay, plus, ooh, that's nice because that's we know that means addition, right? So 53 plus, and then $4 per kid. $4 per kid. Well, we know that kids are represented by x in this case, and per means to multiply. Okay? Well, and we can put those together to be 4x. We want that total, the $53 plus the 4x, all of that needs to be equal to at least $69 in order for her to reach her goal, right? Do you think she's going to be okay with making more than that? Most likely, right? So it's okay if that's greater than, but she's also okay with it equaling $69. For whatever goal she has, that's her minimum, okay? So what we're going to do is we're going to take that inequality, And we're going to solve it just like we did in our last few lessons. We've got 4x plus 53 is greater than or equal to 69. Well, just like with our equations, just like with our other inequalities, first we're going to take away what we're adding, right? We're going to get rid of addition first, or subtraction, whatever shows up. In order to get rid of the addition, I'm going to subtract 53 from both sides. So 53 minus 53 is 0. We're left with 4x. So notice, like, I'm sorry, and I'm stopping real quick. Notice the x, like, wasn't literally the first thing, okay? It came after the 4. That's okay. It's still in that first term, okay? And the same was true with the last problem as well, right? The way we wrote it, it was in the first term, and that's what we want to see, okay? So when it said, like here it said, write the inequality so that the x term comes first, right? This is the x term, all right? The 2 just happens to be attached to it. So the same thing is true here. Notice, like in the problem, the 53 came first and then the 4x, but we wrote it backwards from that, okay? But that's, you know, it helps us take away the 53 and so on. All right, bring your symbol down, and then 69 minus 53, let's see, we've got 16. Okay, now I'm multiplying in the problem, so to get rid of it, I'm going to divide. Whatever I do to one side, I have to do to the other. 4 divided by 4 is 1, so those cancel, and we're left with just x, or 1x, on the left. Symbol stays the same. And then 16 divided by 4 is 4. So what that tells us is that Helena needs to babysit at least 4 kids to meet her goal. Okay? It's a pretty sweet babysitting deal if you think about it. $53 like flat fee, that's pretty cool. Okay, number 3. This is number 1 on your quick check as well, so definitely make sure to write this down. The sum of 4 and 5/10 and 1/3 a number is equal to, at most, 38 and 9/10. What are all the possible values of the number? How would you write an inequality that could be used to solve the problem? Now, I didn't write all of them down, but in the problem, you're going to be given 4 different answers. And so we're going to build the correct answer. That way you can make sure you look for the right one. Okay, so first off, the sum of, that's the answer to an addition problem. So I know that I'm going to be adding, right? There's my adding. The sum of 4.5, or 4 and 5/10, okay, so we could say 4.5, and 1/3 a number. Well, another way to say that could be like 1/3 of a number, and if you're taking 1/3 of a number, then you're multiplying it by 1/3 or dividing it by 3. But we could say 1/3 multiplied by a number, and I think they use the letter n. Okay, so we'll say n for number. Okay, so the sum of both of those is equal to, at most, 38.9. So once the problem says is equal to, that's when you know you're getting ready to find your symbol, and then whatever's left goes on the other side. So in this case, the other side is going to be 38.9. So at most, let's go look at our other phrases. Okay. At most is this guy here. Less than or equal to, okay, at most. So that means we can hit that number, but we can't go over it. Oh, hold on, I'm flipping the wrong direction. There we go. So less than or equal to. Less than or equal to. Okay, so there's our inequality. Now, the only thing I haven't done yet is these are backwards according to like the pattern or the process that we would normally write it. And it is a good habit to get into, especially when you get into higher levels of math and you have more exponents involved and stuff like that. So usually what happens is that you write things in order of the exponent, which in this case we don't have any, but we do have the variables. So we're going to say 1/3 n plus 4 5/10 is less than or equal to 38.9. So just by getting it to this step, you would have the correct answer. That's all we need. But then it just says where n is equal to the number. And each one of the answers that you're going to run into have that. But so this right here, this is what you're looking for with the answers. You do not have to solve it unless you want to for extra practice. But reach out if you have other questions, especially when it comes to building those, the inequalities. I know it can get confusing, so hang in there, and I'm here to help if you need me, okay?